Perpendicular bisector. This is one of the things that we actually talked about within triangles before, about how you use it within a progression. But today it's not anything to deal with progressions. It's not anything you have to worry about setting up with proofs or anything. What I want you guys to think about here is just really easy. What does a perpendicular bisector do? It bisects perpendicularly. Okay. In other words, if you have a segment,
I like the Christmas spirit.
if you guys, we done? Okay. When you have a segment and there's a what you call a perpendicular bisector to the segment, that just means that something hits the segment, it cuts it into two congruent parts, hence the bisector, and it's just perpendicular. So you get two things. You get right angles and you get segments that are equal to each other. Okay? It is extraordinarily simple to see. Now, if I do it this way, you guys okay that you get two right angles? Correct. You get right angles on both sides there. All right? Now, if you think about it in terms of what could become, can I say it? What could become a, if I wanted to make this into a triangle, without drawing the legs there, what would this vertical part, can I say it's congruent to itself? So just by doing that, what do you have right away? What do I have? I have side angle side. So without even drawing the sides of the triangle here, I get side angle side. So basically what this means is, no matter how short or how long the perpendicular bisector is, if you are anywhere on a perpendicular bisector, you're always equidistant to the sides on the end because of side angle side. So if you're on a perpendicular bisector, you're always equidistant to the endpoints of the segment that's bisected. It's a long-winded word for, bless you, not for that, but it's a long-winded word for CPCTC. That's what happens. Okay. You are equidistant to the ends. Okay? You're equidistant to the ends. And the reason that it happens is because a perpendicular bisector creates side angle side. And then that means no matter where you are on that bisector part, you're always be the same distance across. Because you'll always have a reflexive side, no matter where you put it. Even if I put them here, here to here, I still have side angle side, no matter what. Okay? It's a nice trick that happens. So what this allows you to do is just basic algebra. It's really, really difficult. Good luck. But some wrestler knocks some kid upside the head. Cody? You lost him. Need the autograph.
Wait, can you scoot back a little bit?
When he's done, we gotta clap like this Jordan.
You put on the lights up so you see your prints out.
Is he gonna go on there?
You know where the guys? Hey, Austin, you know where there's a printer out in the hall by FTLA? There's a printer out there. Would you mind grabbing that real quick?
I can't wait to our printer is out.
So when I become president,
You keep saying
I'm gonna be president.
Shh. Guys. All right. So basically it allows you to do stuff like this. Come on. Come on, guys. It allows you to do stuff like this. It is extraordinarily simple. But you're going to have some information that'll be given to you. And it's going to ask you to find some stuff. Okay? What happens is, where do you print out? All right. What it's going to do is it's going to give you some information. It's going to say that you have a perpendicular bisector. So whenever you have information about something that you can mark in a diagram, what do you think you should do? Mark the diagram. I'm trying to say what. That just tells me you're not thinking. You gotta eat, man.
Can I be there?
You with the paper?
No.
There you go. So, what happens here, it tells you exactly, it tells you something in the information. Just like before. Whenever in geometry, or whenever we have definitions and stuff like that, you can always mark diagrams. Think about when we had a bisector. You knew that two segments were congruent, or two angles were congruent. You had a midpoint, you had two segments that were congruent. If you were perpendicular, you knew that you had right angles that were formed, and so on. You were always able to mark your diagram to show it via proof. Well, now we take this idea of marking diagrams, instead of going into a proof, we'll be able to take it and set it up and solve for things algebraically. That's the switch now that we're going into. Like I said last week, we're done with the proofs, guys. There's nothing left except for whatever we have to throw on the final. The rest of it, it's algebra and understanding your definitions. Last week, or last Monday, we talked about that mid-segment. The mid-segment was the segment that connected the midpoints of a triangle, okay? That was very, very straightforward. You guys flew right through that, okay? Today we'll talk about the perpendicular bisector segments. Tomorrow we'll talk about angle bisector segments. Wednesday and Thursday we kind of take, it usually takes about a day and a half to get through the medians and altitudes. And then Friday, it's quite literally what's called the triangle sum theorem. It takes about 10 minutes, and that's chapter 5. That's how fast this chapter goes. There's really not much material to it. So when you get to this part, then you know you have a perpendicular bisector, which means those are right angles, which means these two segments are the same, which means this is a reflexive side, which means those are the same. It's that. That's how fast this is. If you're on the perpendicular bisector, you're equidistant to the endpoints because it creates an isosceles triangle. Perpendicular bisectors will create isosceles triangles. It's that plain simple. Algebraically, what's that?
Do you do that every time?
If you're on the perpendicular bisector, yeah.
Yeah.
Yep. If you're on the perpendicular bisector, this always happens. Always. All right? So what do? 2 step. Oh, yes. What's up?
Why does it make the bottom 2 lines equal?
It's perpendicular bisector, so it does 2 things. It's perpendicular and it bisects it. It's cutting the segment in half. So it cuts it into 2 parts. It's just, instead of just saying 2 segments are perpendicular, it's not just perpendicular, it's also perpendicular and a bisector. So it does 2 things. That's all. It's just making a combination. So algebraically, you have 2y plus 9 is 5y. What do? Move that over. Y is. A lot of times then you have to substitute back in. So what's 2 times 3? Plus 9 is. And 3 times 5 is also 15, so it doesn't look like we screwed that up. Okay. It is pretty straightforward. Do the same thing with the other ones because they're equidistant, so they have to be equal. You're right. Subtract 3x. You get 4. Last time I checked, 7 times 4 was 28. 3 times 4 is 12 and 16 is. So we did not done goof. All right. It is. Yes, sir.
I have a serious question.
That's funny coming from you.
Forrest Gump.
Then you just add 2
Huh?
by
Pick one.
I'm busy.
You just add 15. No, it would be 30.
I like Forrest Gump.
What?
So that's what JL would be.
Oh, for this one?
Yeah.
Yeah, the whole thing is 15 and 15. Same deal.
Wait, can you go back for a second? Why'd you write 15?
It was asking what JK was. So 2 times 3 plus 9 is 15.
Oh,
Now, the other one, I'm just going to blow up the picture here. This is the perpendicular bisector. Solve for everything. Take a minute and do it. All right, so like I said, once you guys get going into this stuff, you'll notice that it is quite literally very straightforward. There's not a lot of craziness here, okay? As long as you remember what you're setting up here and you're not making a stupid mistake with your algebra, it's going to be really easy. Pick on the little guy, move the x, move the 5 at the same time. And you get 5, which means both segments are going to be 10 here, 10 here, so you get that. Same deal with the y values, set them equal to each other. 2y plus 15 is 9y minus 13. Moving things around, 28. So you substitute back in 8 and 15, I believe, is 23. 36 minus 13 is also. And it does not appear as though we've done goofed. Ah, what if I wanted to figure out what the segment ZX was? What if I want to figure out what the segment ZX is?
Would you just add 23 plus 7?
I don't know. Let's see. So if I have a right angle, a 10, and a 23, how do I figure out that? Pythagorean theorem, good. Remember what the Pythagorean theorem is, guys? I know we haven't really talked about it yet, but this book tends to use it a few times before they actually even show you about it. Because they're asking that you actually remember something from middle school. I know, it's a lot. So, Pythagorean theorem, what is it?
It's like
A squared plus B squared equals C squared.
A squared plus B squared equals C squared. See, everybody knows that one, we hope. Now, of those 3, there's only one of them that you have to be concerned with. It's the hypotenuse. Which one is always going to be a hypotenuse, A, B, or C?
C.
C. Okay, bueno. So,
Gracias.
de nada. The hypotenuse in a right triangle is always the segment across from what? Good. It's always across from the right angle. Hypotenuse always has to be across from the right angle, and it always will be the longest segment. There's a reason for that. In a triangle, can you have an angle, if you already have one 90-degree angle, can you have another angle bigger than 90? No, because then you'd have more than 180 degrees. So we deal with what we'll talk about in 5.5. It's called the triangle sum theorem. Biggest angle gets the biggest side across from it. Smallest angle gets the smallest side. It's that straightforward. Hence why it only takes 10 minutes to talk about it. So if I wanted to set this up, I would use x squared plus 10 squared is 23 squared. Now in your calculator, you can press buttons and rewrite that all day long, or do it the easy way. X squared will equal 23 squared minus 10 squared. So take your calculator. I want to show you guys how to use the second answer button real quick. A lot of times in this class, we're going to do stuff with the answer key. You probably never used the answer button before on the calculator. It's where your last value is stored from when the last time you hit enter. So here I would just type in 23 squared minus 10 squared, and I'd hit enter. I get 429, okay? Now I want to take the square root of that. Now I could type in square root 429, or I can do this. I believe it's the same keystrokes on your calculator, just in a different position. Second for your square root, and then hit second negative symbol. It brings up ANS, stands for answer. That means it's going to put underneath the radical whatever your last answer was. Well, my last answer was 429. It's just a shortcut. It's a shortcut key. Okay? We use it all the time. We always use this answer key. Okay? Do you not see it? The answer is the negative symbol by the decimal point, I believe.
No, I got it.
Okay.
And then, yeah.
So then we would say that ZX segment, depending on how I ask you to round it, usually I ask you to round it 2 decimals, would have been 20.71. From there. Right? Does that make sense? I just wanted to show you guys where those buttons are because we're going to use them a ton. Okay, we're going to use it a lot. It's a nice shortcut to have. What's wrong?
I don't know. This is weird.
Let me see. What'd you get?
It like put it the same. I don't know.
Oh, you hit it twice. That's why.
I know, but then I'll put something like that.
Okay. Did anybody's calculator just say 429? Root 429? Okay. That's the one benefit of this calculator is that it will automatically put it in simplified radical form. That just means that the square root of 49 can't be simplified. 429 can't be simplified. In order to get the decimal equivalent, you know how to press that on this one? Double arrow. And that'll come out. Now, if it was the square root of 428, I think that'll work. If you type in square root of 428, you get an answer of 2 root 107. That would be what's called simplified radical form. It's not going to happen too much right now, but later on, especially in chapter 7, when we get back from break, we're going to be keeping everything in simplified radical form. These calculators do all that for you, so you don't have to worry too much about it. Okay? I just wanted to remind you guys about Pythagorean theorem. So, in a triangle, how many sides do you have? 3 of them. So in a triangle you have how many sides? 3 of them. Which means, how many different perpendicular bisectors could you have in a triangle? 3. 1 for each side. So if you draw this out, and kind of guesstimate it here a little bit, it's about a midpoint here and here. Comes up here. It's about here. And then if I do another one here, get all these right angles. It's not the greatest looking picture, but what happens here, and I was trying to draw this a little off-centered so it wouldn't work out to be directly in the middle. What happens here is that you get, excuse me, since you have 3 sides in a triangle, you could have 3 perpendicular bisectors. And you just kind of draw them out that way. Now, when 3 or more segments intersect at one point, move this over here. When 3 or more points intersect at one point, it's called a point of concurrency. It's called a point of concurrency. It's a weird name for 3 or more segments intersecting at one spot. Okay. Now, when we talk about this week, we're going to have perpendicular bisectors, angle bisectors, medians, and altitudes. All of those things, that means that there's going to be 3 of them in each triangle. 1 for each segment, or 1 for each angle. Where those things all intersect, there are going to be three different what are called points of concurrency. Those things all have more specific names. And that's what the vocab of chapter 5 comes in. With these points of concurrency, when we have what are called perpendicular bisectors, the point of concurrency is called a circumcenter. The point where all three of those perpendicular, write this out, is the point where the point where three perpendicular bisectors intersect. It's called the circumcenter. What'll happen is that when we get into diagrams later on, when we start mixing all these things together, it'll say point R is a circumcenter. Point R could be an incenter. Point R could be an orthocenter. There's three different names that you'll have to keep up with. Okay? As long as you know that, you'll know what to do. So perpendicular bisectors, they all run into each other at a point called a circumcenter. That point has specific values then. From that point, oops, to vertex are all congruent. From that point in the triangle to the vertex is all congruent. Basically, it's this. So I can draw this. This segment, and that segment. Those three green lines would all be the same. That's new. I haven't done this before. Instead of, you know how we've done three sides, we've done one tick mark, two tick mark, and three? Well, here I've got a fourth segment. Instead of putting four tick marks on there, a lot of times they switch to just like a V. Is that okay?
Sure.
What's that? No, that'd be fine. Yeah, you're a one-off. Okay. It's just another way of showing a congruency. It's just the same thing if you drew a circle on a segment, on two different segments, just means they're congruent. Okay? So what happens here is that you get three segments, different segments that are congruent. Point to vertex. So we're going to have a couple of things here. We're going to have point to vertex, vertex to side, point to side, and it all depends on which one of these things we're working with. That's where the vocabulary comes into play big time in 5. Okay? Just keeping it straight. The math isn't hard, it's just knowing which segment you're working with. All right? Let me show you an example. Oh, right down here. Okay, so that point vertex is here. Don't draw this, I have this written out for you. I figured I'd save some time and just run it off for you. So let's move this stuff forward here. And you'll see how the instructions and all this stuff is going to work. Now, like I said, a lot of these things you're going to have. They just breaks it off out of that. Thank you. So like I said, these types of problems are going to have big picture problems. And it's going to give you information. Here it says the perpendicular bisectors of the triangle meet at point O. That means these are all your perpendicular sides. Perpendicular here, and it means all of these segments have been bisected. Those are the same. and you just walk yourself around. Because what does a perpendicular bisector do? It creates right angles and it cuts segments into two. Just mark the diagram. Also, point O is where they all run into each other. If that's where they all run into each other, from that point to what spot is also all the same. The vertex. So which are the three segments that are also congruent to each other? Where are your point to vertex segments?
S O M O.
And that would be a side. S would be a side.
My bad.
M O.
M O. N O. M N O. Q R F.
From the point to vertex. Those three segments wind up being the same. That's what you do with the diagrams. You just read them and you mark them first. And now you fill in the blanks. Well, if MQ is 20, what's QN? 20. NR is 26, what's RP?
26.
22 and?
This diagram doesn't have nothing.
Guys, come on. If ON is 26.8, what is OM? What is OP? Yes. Well, we'll have homework eventually. No. Now, that also means we can find, I can find OS. I can find OR.
Wrong triangle, Mr.
Ladies and gentlemen, come on. So I want you guys to find those missing segments. We'll call it X, Y. So what I'm trying to get you guys to do here real quick is I want you guys to find OS, OR, and OQ. I've already redrawn the right triangles that you're going to use. You need a calculator. Yes, you need a calculator. All right. Take a couple of minutes and work it through. Okay. You guys want to round out to 2 decimal places? Guys, hey, enough. First one. If I round out to 2 decimal places for all these, I get 15.3 for the first one. You okay with that? You guys get 15.3 on that one? Second one, see 26. Square root of that. Oops.
Error.
Nope. $6.5. I go to 2 decimal places on that one. If you're not getting these answers, let me know. What was the last one? 20. The last one was 26.8 minus 20. Oh. 17.84 is what I'm going to get on that one. Okay? Everybody get that? Do you guys remember how to round?
Yes.
It's expected that you know how to do that. We do a lot. It is pretty straightforward stuff. There's not a lot of crazy here, all right? Just remember, the only other thing I would say is that if you were, I don't know, you'll figure it out. I don't know why I had two of these. This second one wasn't supposed to be on here. I copy and paste the wrong thing. It's just that top line.
That's not the semester.
All right. There you go.
Thank you.
If you give me a sec, I'll load this up. I'll throw a couple on the board for you. Ladies and gentlemen, this should not be a discussion point here.